Hey everyone! Before we start today's lesson, I have a quick story to tell you. So I was sitting around and I was thinking about how wonderful my students are, and I thought they deserve a treat. So I decided I would go ahead and make some brownies for them. Well, as I was making this pan of brownies, I thought, well, I'm not sure that one pan of brownies is going to be enough for all of my students because I have 42 students and I could only cut this one pan of brownies into 28 pieces. So I decided to go ahead and make a couple more pans of brownies. So I ended up with 3 pans of brownies and each pan had 28 pieces. And I thought, well, that's definitely enough for each student to get one piece, but how many pieces could each student get if I divided it up equally between all my students? So I put all these facts together and I thought, how can I make this a math problem? If I had 28 brownies per pan, 3 pans of brownies, and 42 wonderful students, how could I figure out how many brownies each student gets? Well, what we're going to be working on today is coming up with numerical expressions to help us figure out problems like this. So, our lesson today on numerical expressions. Before we get started, you're going to need a few supplies out. The first thing you're going to need is a pencil. You're also going to need your math journal open to the next clean page, of course. And you're going to need your math textbook open to page 43. So I want you to pause the video and make sure you have all those supplies out before we can get started. Alright, so hopefully you have your supplies out and let's go ahead and get started. The first thing I want you to do is open your math journal to the next clean page and make sure that you have the following things written down. First of all, you're going to need to have the title, which is Numerical Expressions. And you're also going to need to list our learning goal and the definition of numerical expressions. Our learning goal for today is that you will be able to use a numerical expression to describe a real-life situation, just like my situation with the brownies earlier. Now, what exactly is a numerical expression? It's a mathematical phrase that has numbers and operation signs, but does not have an equal sign. So this is an example of a numerical expression. 8 times 10 plus 15. Now, as you can see here, I have numbers and I have symbols, but I don't have an equal sign. So it's basically like a math problem without an equal sign, without having to solve it. All right, so go ahead and pause this video. Make sure you have all these things written down neatly in your math journal. All right, so hopefully you have these things written down in your math journal, and let's go ahead and move on to our math textbook. You should have your math textbook open to page 43. Now at the top you see that we have the definition of a numerical expression, which you already have in your math journal. So let's get started with our first problem here. Tyler caught 15 small bass and his dad caught 12 small bass in the Memorial Bass Tourney. Write a numerical expression to represent how many fish they caught in all. So I'm supposed to come up with a numerical expression with numbers and operation symbols, but I don't have to have an equal sign. So let's figure out what we're going to be doing. So first of all, I know that Tyler caught 15 small bass, and I know his dad caught 12 small bass. So I'm going to come up with a numerical expression to show how many fish they catch all together. If I'm going to figure out how much they catch all together, I know that I'm going to be combining 15 and 12 using addition. So I'm going to write 15 to show how many Tyler caught. I'm going to add that to how many Tyler's dad caught, which is 12. So 15 plus 12, that's our first numerical expression, and it represents how many fish they caught in all. All right, let's go ahead on down to the bottom of page 43. On the bottom of page 43, you'll see that we're not always going to use addition to show numerical expressions. Sometimes we're going to use subtraction, multiplication, and division. So first of all, we see another addition problem right here. Emma has 11 fish in her aquarium. She buys 4 more fish. So again, we're going to be using addition to show how many fish she has altogether. So our numerical expression would be 11 plus 4. Sometimes we're also going to use subtraction. Lucia has 128 stamps, but she uses, keyword uses, that means she takes away from her original amount, 38 stamps on party invitations. So she's starting off with 128 stamps, but she's taking away how many? She's taking away 38. So we would write 38 in the blank here, and you can also do that in your math textbook. Sometimes we're going to be using multiplication. Carla buys 5 books. Each book costs $3. So we're starting off by looking at how many books she buys, which is 5, and we're not going to be adding together the cost of each book. We're going to just multiply the number of books she buys by how much each book cost. So each book costs $3. So if I multiply 5 times $3, I would get how much money she spent altogether. So my numerical expression here is 5 times 3. Sometimes we're going to be using division. So in this problem here, we see that there are 4 players and they share 52 cards equally. And this is kind of a key word here, equally. If I'm splitting something up equally or I'm dividing it into equal groups, that means I'm going to be using division. So I'm going to mix up my numbers here real quick. I'm not going to be putting them in order. I'm going to start with how many cards are being used, which is 52. And I'm dividing that by how many players there are, because each player is going to want an equal number of cards. So I'm going to divide 52 by 4. I'm going to be putting the 52 cards into equal groups and splitting them between 4 different players. So sometimes I'll use addition, sometimes I'll use subtraction, multiplication, or division. Now sometimes you might also have more than just 2 numbers in your numerical expression. So now go ahead and look on page 44 at the example 2. Sometimes we're going to have expressions with parentheses. The meaning of the words in a problem will tell you where to place the parentheses in an expression. So in this case, we have more than 2 numbers here, so we have to read through this problem carefully. It says which expression matches the meaning of the words. So let's read through our problem. Doug went fishing for 3 days. Each day he put $15 in his pocket. At the end of each day he had $5 left. How much money did Doug spend by the end of the trip? So I'm going to go over here and make sure I do what the instructions are telling me to do, which first it tells me to underline the events for each day. So each day he puts $15 in his pocket, and each day he had $5 left at the end of the day. I'm also supposed to circle the number of days these events happened. So this happened for 3 days total. So what's the question I'm actually going to be making a problem for? The question says, how much money did Doug spend by the end of the trip? So I want to know how much money he spent. I don't want to know how much money he saved, how much money he had left. I want to know how much money he spent. So I know that to figure out how much he spent for 1 day, I would take the number of dollars he started with and take away how much he had left at the end of the day. So if I do 15 minus 5, that's going to tell me how much money he spent after 1 day. Now, that doesn't get me the answer to the question. The question said how much money did he spend by the end of the trip. This is just what he did after 1 day. So after I do 15 minus 5, I'm going to have to figure out how much money he spent after all 3 days. So in order to do that, I'm going to multiply the amount that he spent on 1 day by 3. Now as you can see here, I have added in parentheses. Well, I haven't added it in, the textbook did. But I have added in parentheses because parentheses tell me what I need to do first in a problem. So if I see parentheses, that means I have to do that part of the problem first. So I have to do 15 minus 5, which is going to tell me how much he spent in 1 day. And then I'm going to multiply that amount by 3 to figure out how much he spent over 3 days. So once I've done that, it's going to help me write an expression to represent how much money Doug spent by the end of the trip. So the reason I added in parentheses is to show that that is what I want to do first. I have to figure out how much he spent in 1 day first. So I want you to add something to your math journal real quick. So get your math journal back out. And at the bottom of your math journal, I want you to add the following notes. Parentheses. When I see or use parentheses in an expression, I must complete the operation in the parentheses first. So I forgot my period right there. So I'm going to add that in. So I'm going to go ahead and also list an example because it shows that there's parentheses here. So I would do the problem inside the parentheses first before I multiplied by 7. So go ahead, pause the video, and make sure you have these notes recorded in your math journal. All right, so now that you have those notes recorded in your math journal, let's look at one more problem before it's time for you to work on your turn problems. So now we have our final example, example 3. We have a numerical expression written for us, 20 minus parentheses 12 plus 3 end parentheses. So we have to figure out which one of these word problems matches this expression. So let's first start with this problem right here. Kim has $20 to spend for her fishing trip. They're doing a lot with fishing today. She spends $12 on a fishing pole. So she spends 12 of those $20, but then she finds $3. So if she spends $12 and she finds $3, how can we make that into an expression? So let's first of all look real quick at what she does, what the order of events are. So first of all, she has $20. We know she starts with $20, and that matches what the expression has right here. She starts with 20. What does she do next in this problem? She spends $12. So go ahead and fill that in your math textbook as well. Kim spends $12. Well, so far we match because we have $20 subtracting a $12 amount right here. So let's see if the rest of the problem matches. Then, so our next event is she finds $3. So if Kim finds $3, would we want to add that to the $12 that she spent? Would this match this expression up here? The answer is no. This does not match because she spends $12, but if she finds $3, we would want to add that $3 to the amount that she has, not add it to the amount that she's spending. So let's look at this next problem to see if this problem works over here. Kim has $20 to spend on her fishing trip. Again, that's the same start as the other problem. She has $20. She spends $12 on a fishing pole. Okay, she does the same thing, takes away that $12 and spends it on something. And she spends another $3 on bait. Okay, so how much money does Kim have now? So let's list the events in order. So first, Kim has $20. That's the same thing. What happens next? She spends $12. Okay, so far we have $20. She spends $12. What does she do with the other $3? She spends it as well. So she spends $3 and she spends $12. So if we combine this amount and we subtracted it from 20, would that tell us how much money Kim has now? The answer is yes. It does answer the question how much money she has now. So I want you to pause the video really quick and I want you to discuss this question really quick. Why is spending $12 and then spending $3 represented as addition? So go ahead and pause the video and discuss the answer to that. So hopefully you had a discussion about why they're added, and the answer is because I'm subtracting both of these numbers from 20, so I would want to add them first and then subtract them from 20 so that I have the total amount that she has left over. Now here's my next question. And I want you to pause the video and answer this question as well. Suppose I show the expression this way. Suppose I did it $20 minus $12 minus $3. Would that work? And why? Or why not? All right, so hopefully you paused the video and discussed this. The answer is yes, this would have worked as well. We would have gotten the same amount. So we could show the expression two ways, but both of the ways work. They would both get us the same amount in the end. So sometimes I'm going to give you a problem and you have to come up with an expression, and there might be more than one way to answer that expression or find the answer to that expression. So the last thing that you're going to be doing today is you're going to be writing down these word problems in your math journal, and you're going to be answering them on your own, and then hopefully you'll have time to discuss them together. So make sure that you write down the problem and the answer in your math journal. There's 5 different problems. The first 3 problems you're going to be writing an expression to match the words. And for the last 2 problems here, you're going to write your own word problem that matches the expression. So go ahead, pause the video, and answer these 5 questions in your math journal.